Hi everyone. Next topic is a response of high pass RC circuit for exponential input signal. Now this is the exponential input signal we are going to apply to the high pass RC circuit. We already know that now exponential input signal has zero value for t less than or is equal to 0. For t less than or is equal to 0, it has zero value, and for t greater than 0, its response increases exponentially with respect to time. Increases exponentially with respect to time. And this can be represented mathematically as for t greater than 0, it is v into 1 minus e power minus t by t. T by tau. It is tau. Here v represents the amplitude, t represents the time period, this represents the time constant. We are going to apply this signal to the high pass RC circuit, which is consisted with resistor and capacitor. Now we get this response after applying the exponential input signal to the circuit. Here the dotted line represents the input signal and thick line represents the output signal, Vi and V0, and this is final output signal. Now coming to the operation of the circuit is classified into two cases. First case is for t less than or is equal to 0. For t less than or is equal to 0, the input signal is 0. The input signal is 0. So whenever we can apply that 0 input signal to this circuit, initially we can assume that the voltage across the capacitor is taken as 0. That means there is no voltage across it. Then for the 0 input voltage, the voltage across the capacitor is 0 and there is no flow of current. So because of that, the voltage across the resistor is also equal to 0. The voltage across the resistor is also equal to 0. Therefore, that means for t less than or is equal to 0, the output response is also equal to 0 because the capacitor is not responded for the 0 input signal and there is no flow of current through the resistor R and the output response is 0. Now coming to the second case, in the second case, the input signal increases exponentially for t greater than 0. If we apply this signal to the circuit, if we apply this signal to the circuit, the capacitor starts charging from its initial value to the final value. But the charging motion of the capacitor is in exponential motion for the exponential input signal. Because we are applying an exponential input signal, for the exponential input signal, the voltage developed across this capacitor is also in exponential motion. Because of this charging, it happens through a resistance R. It happens because of some current flowing through a resistance R. That means because of this current, some voltage is developed across the resistor, that is output voltage, and it also increases exponentially. Now the exponential input signal is defined as Vi, that is equal to V into 1 minus e power minus t by t, that is represented with equation number 1. That is represented with equation number 1, basic input signal. Next, consider the basic expression for high pass RC circuit, that is written as Vi, that is equal to 1 by C into integral of I dt plus I into R. Therefore, Vi is equal to, here we know that the value of I is nothing but the current flowing through the resistor R. The value of I, this is the current flowing through the resistor in the loop. Current flowing through the resistor in the loop. This is the path. Current. That current is nothing but I. So because of this current, some voltage is developed across this resistor, that is V0. Therefore, V0 is equal to, we need to write V0 is equal to I into R. V0 is equal to I into R. But what is I? V naught by R. The same is written here. The same is written here also. So I, that is equal to V naught by R. 1 by C into integral of V naught by R dt plus I into R is nothing but V naught. Now we know the expression for Vi in equation number 1. Substitute that value in this equation. Therefore, V into 1 minus e power minus t by t, that is equal to 1 by RC into integral of V naught dt plus V naught. Differentiating the above equation with respect to t. Differentiating the above equation with respect to t. That means this equation. We can get, we know the differentiation of 1 is 0, therefore this term is vanishes. V into e power minus t by 2. Here V is constant, therefore e power minus x is equal to e power x. Therefore V into e power minus t by t into, again differentiation 2 minus t by t, therefore we can get 1 by t. Minus into minus plus. That is equal to 1 by RC into integration of V naught dt. By applying differentiation to this term, we can get V naught plus dV naught by dt. Now take inverse Laplace transform. Take Laplace transform to this equation. Take Laplace transform to this equation. Therefore, that is equal to V is constant, T is constant. Therefore, V by T is constant here. Whole. Therefore, Laplace transform of e power minus T by T. Laplace transform of minus T by T. Inverse Laplace transform is 1 by S plus 1 by T. That is equal to 1 by RC is constant. Laplace transform of V naught is equal to V naught of S plus Laplace transform of dV naught by dt is nothing but S into V naught of S. Therefore, V by T whole by S plus 1 by T, that is equal to, here V naught of S is available, here V naught of S is available, take V naught of S as common. Therefore, V naught of S into 1 by RC plus S. V naught of S into 1 by RC plus S. Therefore, V naught of S is equal to V by T whole by S plus 1 by T into S plus 1 by RC. V naught of S is equal to V by T whole by S plus 1 by T into S plus 1 by RC, that is represented with equation number 2. That is represented with equation number 2. Therefore, V naught of S. Now, by using partial fractions expansion, we are going to simplify the expression equation number 2. But here there are two cases. First case is if T is equal to RC, that means if this value is not equal to RC, that is first case. If this T is equal to RC, that is second case. Now coming to the first case, if T is not equal to RC, then V naught of S is equal to, write the same expression, that is V by T whole by S plus 1 by T into S plus 1 by RC. Now apply partial fractions to this equation. Therefore, you get V naught of S is equal to A by S plus 1 by T plus B by S plus 1 by RC. You can get equation number 3. Now take LCM of equation 3. Therefore, whenever you can take LCM, V naught of S, that is V by T, numerator cancel, this one cancel. Therefore, A into S plus 1 by RC plus B into S plus 1 by T. Now, by simplifying these two equations, we get A and B values. That means to get the value of A, substitute S is equal to minus 1 by T. To get the value of P, substitute S is equal to minus 1 by RC. Now, substitute S is equal to 1 by minus 1 by T in this equation. When S is minus 1 by T, the bth term is equal to 0. Therefore, remaining is written as V by T, that is equal to A into minus 1 by T plus 1 by RC. Minus 1 by T plus 1 by RC. Therefore, A is equal to V by T whole by minus 1 by RC minus 1 by T. Therefore, that is equal to V by T whole by, take 1 by T as common in denominator. So 1 by t is taken as common and the remaining is written as minus 1 plus t by rc. It can also be written as t cancel v by t by rc minus 1. This is the value of a. Similarly, substitute the value of s with minus 1 by rc. Then the term a is 0 and the remaining is written as v by t, that is equal to p into this is s minus 1 by rc plus 1 by t. Next, where b is equal to p by t whole by, move this to left side, 1 by t minus 1 by rc. Take 1 by t as common. Whenever 1 by t is taken as common, 1 minus t by 2 rc. T cancel. Therefore, b is equal to v by 1 minus t by rc. So we obtain the expression for a and b. So this is the expression for a and this is the expression for b. Now substitute these values in v naught of s. We get v naught of s is equal to a by s plus 1 by t plus b by s plus 1 by rc. So what is a? V by t by rc minus 1. What is b? V by 1 minus t by rc. Now after substituting the values of a and b, take v by t by rc minus 1 is common in both the terms. Now multiply and divide with minus this term. Therefore v by t by rc minus 1 whole into 1 by s plus 1 by t. So numerator and denominator is multiplied and divided with minus. Therefore t by rc minus 1 goes outside and minus is left here. 1 by s plus 1 by rc. Now apply inverse Laplace transform to this to the equation. Therefore v by t by rc minus 1 whole into e power inverse Laplace transform of 1 by s plus 1 by t, that is e power minus t by t, minus inverse Laplace transform of 1 by s plus 1 by rc, that is e power minus t by rc. That is taken as equation number 6. Next, coming to the second case, this is the expression for output response if t is not equal to rc. Now coming to the second case, if t is equal to rc, then we know the expression for v naught of s, that is equal to v by t whole by s plus 1 by rc into s plus 1 by t. If t is equal to rc, then it can be written as v by t whole by s plus 1 by t whole square. Now apply inverse Laplace transform to this equation. Therefore v naught of s inverse Laplace transform is v naught of t, that is equal to v by t is common, right, same thing, 1 by s plus 1 by t whole square. Laplace transform is t into e power t minus t. Therefore t into e power minus t by t. Now this is the expression for output response if t is equal to c. That means if the time constant, this is the expression for exponential response of high pass RC circuit. And if you observe this, here the first thick line represents the input, the second thick line represents second, third, four, five, all this represents the output responses. Only first one is the input response. So if you observe this, by increasing the time constant, if you observe this, if you increasing the time constant, then the transmission error between these things will be minimized. The transmission error is inversely proportional to the time constant. If you increase the time constant, the transmission error will decrease. If you decrease the time constant, the transmission error will increase. So that is clearly observed here. That is about the basics high pass RC circuit for exponential input signal. Next, we are going to discuss about the high pass RC circuit for pulse input signal. We already know that the pulse input signal is defined as its value is 1. Its value is 1 from 0 to Tp. That means from 0 to Tp, the input is 1. And for the remaining, that means for t less than 0 and t greater than Tp, its value is 0. That means the input signal is appears only between these two variables, that is 0 to Tp. Before 0 it is 0, greater than Tp it is 0. Now this signal is going to apply, pulse signal is going to apply to the high pass RC circuit, and this is the response produced by the corresponding circuit. This is the response produced by the corresponding circuit. Now the operation of the circuit is divided into so many cases. First case is t less than 0. Next case is at t is equal to 0, the input signal suddenly increases. Whereas for t less than 0, the input signal is 0. At t is equal to 0, the input signal suddenly increases. From 0 to Tp, the input signal has constant amplitude. At a t is equal to Tp, the input signal suddenly decreases to the low value. And for t greater than Tp, its value is 0. For t greater than Tp, its value is 0. Now, coming to the first case, that is for t less than 0, the input signal is 0. For the 0 input signal, the capacitor is not responded for the 0 input signal, and there is no flow of current through the resistor R. Therefore, we get the maximum value, same 0 for t less than 0. That means for t less than 0, the output signal response is also 0. Now, coming to the second case, at a t is equal to 0, the input signal suddenly increases to the maximum value. Whenever you can apply this signal to the circuit, the capacitor is not responded for sudden changes in the input signal. The capacitor is not responded for sudden changes in the input signal. Therefore, it simply behaves as a short circuit at a t is equal to 0. So when the capacitor behaves as a short circuit at a t is equal to 0, the entire signal is transferred to the output terminals. Therefore, we get at a t is equal to 0, V0 is equal to Vi. At t is equal to 0, V0 is equal to Vi. That is the second case. Now coming to the third case, that is from 0 to Tp, the input signal has constant positive amplitude. If we apply this signal to the circuit, because of the constant input signal, the capacitor goes into charging condition. Because of the constant input signal, the capacitor goes into charging condition. That means the voltage across the capacitor increases exponentially. Whenever the voltage across the capacitor increases exponentially, the charging happens because of the current flowing through the resistor R. That means because of this current, some voltage developed across this resistor that is indicated here with V0, that voltage decreases exponentially. That voltage decreases exponentially. That means here, when the input signal is constant, the capacitor goes on charging, that means goes on increasing the voltage across it, and the output voltage goes on decreasing exponentially from maximum value to the minimum value. Again, in the fourth case, at a t is equal to Tp, the input signal suddenly decreases to the low value. Whenever you can apply this signal to the circuit, what happened? The capacitor is not responded for the input signal. That means it behaves as a short circuit. Whenever the capacitor behaves as a short circuit, the same signal is applied here and we can get the same signal as output because the capacitor acts as a short circuit. Whatever the signal you applied here, the same signal is transferred to the output terminal. Therefore, V0 is equal to Vi at a t is equal to Tp. Therefore, you can get the same signal. If you get V as amplitude, the same V is appeared at this point. Now, in the final case, that is fifth case, for t greater than Tp, the input signal is 0. For t greater than Tp, the input signal is 0. If we apply that 0 input signal to the circuit, the capacitor already charges to the maximum value from 0 to Tp. Now, because of the 0 input signal, the capacitor starts discharging through a resistor R with the current I. Because of the zero input signal, the capacitor starts discharging through a resistor R with the current I. So that discharging is decreases exponentially from maximum value to the minimum value. Because of this discharging, some current is flowing through the resistor R. Because of this current, some voltage is developed across this. That voltage is increases exponentially. Whenever the voltage across the capacitor reaches to zero value from maximum value because of discharging, the voltage across the resistor also reaches to the zero value at some time period. Therefore, finally we get this waveform as an output response for the pulse input signal. For the pulse input signal. So this is input, this is high pass RC circuit, this is response. High pass RC circuit for pulse input. Thank you so much for patience.